All right. Hopefully the audio is good. It's been a while since I've done this. Um, Welcome. I don't know if there's anybody here yet. Let me see if I can pull up the. Yeah. So, just give it a few minutes to get situated here. So I got this going. Just check my different views. It looks good. That's going to cause an issue. Okay. Let's move that here. Okay. Sorry, I was had a few last minute connection problems there. Hold on a minute. I need to change the audio. Use the good microphone for that, not the cell phone. All right, that should be better for that. Okay. Yeah, so if there's anybody out there, welcome. Sorry for the little delay, slow introduction here. So what we're going to be doing today is making this part. So this is made out of some kind of, it almost looks like cast iron. It's definitely ferrous. It's, it's way heavier than aluminum, but you can see it kind of cracked right there. You can see all the grain structure in there where it looks like it was cast. So we're going to try to make this today. It should be fairly straightforward. I'm going to probably just substitute this fillet around here with just a chamfer. It's got a keyway in it. You can see down here. If I could navigate, there we go. So fortunately, that is a round keyway, like it's like a semicircle almost. So I think we'll be able to make that just by drilling a hole and then maybe using an end mill to touch up on it. Yeah, so we'll see how this goes. It's the first time I've tried making something that wasn't, given to me through like the Titans of CNC building blocks program or something that I just made up to test something. So first time reverse engineering a part, if you will. So that should be fun. So I'm just going to start by creating a new design here. Create a new project. Actually, we'll use the live streams project. Come on. There we go. New folder. Lawnmower. Come on. Part. Okay. So use the first untitled file there. Save this as a lawnmower part. All right, so first things first, we're going to create a sketch. We're going to use the XY plane. All right. So over here, let's get some basic dimensions going. Sorry if the camera is going to be a little shaky, but oops, that's going to make it worse. Give you an idea of what we're working with here. So that is 3.311. I'm just going to start with a rectangle. .311 this way. Ooh, that's so close. I didn't even think if the material was going to be big enough. So here we're getting 1.993. All right, so our part needs to fit inside that box. Inside there, we're going to have 3 holes. Looking at it here, they look like they're all in a line in the center of the part. I'm going to move this microphone a little bit. So, start measuring the holes. It's like the 2 on the outside are a bit smaller than the one on the inside. Got like 0.313. We'll go with that. I guess I need to make note of that. I was going to create point. It's all in a line. Circle 313. Shoot. I think that was the one that was on the broken lug. We'll do the same thing over here. Probably scraping stuff off. There's a little bit of dirt in there. We'll go 0.314 for both of them, actually. Okay. Then it looks like these do have a, like this one almost looks like it has a bushing in there. I talked to my dad about this when he gave me the part, and he said that he's fine just having this whole thing made out of billet aluminum. Don't need a bushing or anything. I think he'd rather have it break than be way too strong, so we weren't going to try to make it out of steel. So there's no guarantees this thing's going to work, but we're just going to see if it fits and go from there once I get the part to him. So I saw 0.41. Yeah, we'll go with that. 0.41 for the center circle. Okay. So this thing has this kind of diamond shape to it. So I'm gonna just gonna guesstimate that. To start, trying to think if there's a good way to measure the angles. Because obviously the radius on this side is a lot greater, like the angle's wider there than it is here. I'm just going to draw some lines. Using the L hotkey to draw lines. Okay. Well, we're gonna put those at a point. So I'm going to draw a construction line. So I'm going to hit L for line. I think you click it once, hit escape, and now if I select this line and hit X, that makes it a construction line. So it doesn't show up when you try to extrude stuff. Things like that. That's my understanding, at least. So D for dimension, I'm going to say that line is, why is that giving me degrees? I don't like that. I'm going to put a horizontal vertical constraint on that. Interesting. It says it would over constrain it. Let's just try the dimension again. From there to there. Okay, so I'm going to take this length, these parametric dimensions, so it references each other. Put that at the midpoint. What's that guy doing? I do not remember drawing that giant line. Okay. Let's try that again. We'll draw a line from here to here. Make it a construction line. We'll say it's vertical. D for dimension. Here to there. It's that dimension. One time. Divided by 2. Don't know why that was so hard. I'm going to say that this point and this line are coincident. I think there's a better way to do that. I want to snap it to that point. Delete that coincident one. Okay. We'll just snap it and make it do a midpoint constraint like that. We have that. So now I'm just going to try to like eyeball where that radius needs to be. Because this lug at the end, let's get a measurement over that circle. This is not going to be precise. We got there 1.173. I'm just going to say 1.3 is the width. So if we make a line through here, that's 1.3 inches long. And midpoint. That's not what I wanted. Okay. Let's do this while we're here. This circle is collinear with that circle. It's collinear with that circle. Sound good? Sure. I want to move this circle onto that line. I'm going to say this circle is coincident with that line. I'll draw another midpoint line. I'm going to say that that line goes from here to there, and that's that dimension divided by 2. So that fully constrains that. Make that a construction line. Now, at that point is coincident with that line. So that fully constrains that circle now. It's black. So we'll say that that is collinear with that. I want to say, but it doesn't like that. Well, I guess the line is, you can't see my hands while I wave them in front of the screen, but the line's going that way. That's the problem. So if I say this is coincident with coincident. Oh my. Isn't this fun? Still have a lot more to do to get comfortable with this CAD. I don't do any like actual CAD in my day job, so I haven't really touched this stuff since school days. What is this midpoint constraint doing? That's on the line. There we go. I guess that point is coincident with that line. Okay. Now can I move that line? Aha. Okay, so measuring the diameter of a circle is going to be difficult. But I still haven't positioned these circles yet. Oh, Kay Cruzy. I think I know who that is. She says nice camera setups. Thanks. I set those up this morning. Okay, so all right, so instead of trying to measure from the hole to the hole, I'm going to measure from the outside to this edge. What do we got there? 0.27. 2.75. Oh no, it's close. It's not going to be exact, unfortunately. I'm going to go 2.75. That sounds like something that an engineer might have chosen when they were making this part. So from this point to the edge of the part, what did I say, 2.75? Okay, so that circle is now fully constrained. And I'm going to measure from this same edge, using this as like our datum, if you will. That's about 0.25. I think that's the number they would have chosen anyways. So this, okay, so I just see a mistake. That was measuring from the center. I wanted to go from the outside edge, not the center line. Don't know if it'll let me do that though. So we're gonna have to do a little math. So this 2.75, it's gonna be 2.75 would get me from this side to that point plus half the diameter, half the radius. So I'm gonna make another parametric. Let's get those inches out of there. 2.75 plus that diameter divided by 2. Which comes out to 2.907. Okay. So now I'm going to go from this point to that circle, and it's going to be that distance minus half the diameter. Oh, come on. Not that distance. It's going to be 0.25, right? 0.25 plus half of this circle. That seems about right. Okay. So where was I going with this? I was drawing a line. That line was 1.3 inches. So I want this line to be coincident with that point. Gonna go to this screen for now so you can see better. This line to be coincident with that point. And we'll measure over here too. Where's my, there we go. Roughly Should be about the same, 1.3. Maybe it's 1.25. Yeah, I'm gonna go 1.25 inches for both of them. So I'll make this, come on, 1.25. I'm gonna make another line, construction line that goes through here. I'm gonna say that this is 1.25. The midpoint of this line is going to be that circle. And say this line is coincident to that line. This line is coincident to that line. Okay. So I need to make the radius shapes now. So I'm going to go, I think there's fillet. Yeah, fillet. It wants to do edges, faces, and features. So I'm just going to trim these lines while I'm thinking about it. Okay. If I trim that, is that going to get rid of my references? Yeah, I can't get rid of those. But what I can do, I'm just going to finish this sketch. Did I not make this I'll go back and edit that sketch. Make this a construction line. I thought I'd have done that, but okay, so finish the sketch. The reason I did that was because it was calling this two bodies. It was splitting that at that line. So back to our reverse engineering screen. How thick is this? 0.39. Oh gosh. I'm gonna say I think I'm just gonna go 3.4. Lila, can you please stop? We'll go 0.39. So I'm going to extrude this shape 0.39 inches. Sorry for the barking dog. And now we're going to do our fillet. So this line to this line. I have no clue. What, 0.25? We'll see what that looks like. That's not what I wanted at all. I think I probably need to do that in the sketch still. Go back to programming. Okay, so select the sketch, edit the sketch. Okay, so I am trying to get this shape to be a fillet. I swore that you could select two lines. And make a radius like that. Yeah, why is it doing it there but not? Okay, so going back to here, trying to just match up that shape. So it needs to be bigger than that. That goes too far because that goes past center. Maybe it's always going to do that though. No? That looks fairly reasonable. Okay, so that was a chamfer, was it not? Why is it giving me trouble now? Fillet, I meant to say, not chamfer. I literally just did this. Why is it giving me trouble? This thing, I swear. That removed a dimension. Okay. So when I hit F for fillet, it gives me trouble, but when I just click the fillet button, it seems okay with it. I don't know if that's because it's if maybe the F. Anyways, okay. Now what are these top chamfers gonna be? Click the fillet button, not the hotkey. Ooh, so this is. I don't like that because now that's changing. I need to find what still is coincident with that. You know what I'm saying? I need an arc that touches that point. Fill it. See how that backs it off of there. So what I can try to do is change my dimensions after the fact. Uh, hmm. Or I could do a three. Let's try the 3-point arc idea. So I'm going to create arc, tangent arc. That might actually work. Creates an arc with tangency. Select 2 points. Why is it not letting me select anything? So there's a center point arc, a 3-point arc. Let's go from there to there. I guess I have to follow the directions probably for how to select your points. Select the start point, end point, and then a point on the arc. Start point, end point. That doesn't look right though. It doesn't bulge out like that. I'm just gonna make the fillet and then adjust the dimensions, I think. 2.1. 0.3 looks fairly decent. Going back to this view. I also don't know how critical this dimension is. You know? Okay, so what if I... Where was this original length dimension coming from? I see this one is a parametric. D2 divided by 2. Where's dimension 2? almost want to make this bigger too. Oh shoot, that's messing up that dimension like crazy. Go back to this. What if I make this like 0.8? What does that do for me? Literally nothing, apparently. Oh gosh, now it's not centered. I think I must have deleted some kind of a dimension at some point. Let's just get that measurement again. 1.9955. We'll go pi. 1.995. So I'm gonna say that come on. From that arc to that arc. Okay, so that's giving me the center points. Okay, so let's go 1.995 minus the 2 radii. So minus that radii and minus that radii. I think. I mean, that kind of did what I wanted it to. So now if I say that this is tangent to that, it scoots it up. And that's supposed to be tangent to that, but I don't even know. I think I must have deleted that corner. So why did that shift it to the side? And what happens when I change? Did that just like... I swore that like lopsided the part somehow. All right, so I'm just going to say that this is the radii is coincident. The center of that arc is coincident with that. The center of that arc is coincident with failed to resolve. Please delete or modify one of the constraints. Okay, so I want to delete this line. Probably going to regret that. So let's say that arc is coincident with that. Oh, oh, that fully constrains it apparently. It looks strange. Guess I was doing that all upside down too. Okay, so what do we think? Does that kind of look like that? Sorry for the camera shaking. I guess it'd be better to look at it this way. I need to get some kind of way to measure radius or radii. But I think that's... If it doesn't work, we can make another one. But we'll go with that for now, and eventually we can test fit it. All right, so the next thing is this weird, like, kind of sideways oval shape. This one's going to be trickier than I realized, because that's not like a normal looking shape. It almost has like a rhombus, like it's got like square sides that are rounded off. So that was 1 point. say that's 1.52. So I'm going to create a sketch on this top surface. And I'm just going to try to sketch out that rhombus shape. Yeah, it is not in line. Kind of looks like that-ish. All right, so we're going to put parallel constraints on here. So that line is parallel to that line. This line is parallel to this line. I'm just going to make some lines because my brain would be happier if there was like a midpoint line there. Come on, make it a construction line. There we go. And so this line is going to be parallel with this line. And the midpoint, that line, is going to be like that. And I think this would overconstruct. Oh gosh. Let's not do that again. But yeah, if I'm remembering my like high school geometry, I think that should fully, that'll capture both of those lines there. So midpoint of this with that. Let me read what that says if it gives you instructions. Constrains a pointer object to the midpoint of another object. Doesn't tell you like which order to. Oh gosh, I'm rotating that in 3D space. Is that literally what's happening? That was not what I expected. No, that's just an optical illusion. It looks like a square that's like flipping in 3D space, but it's just changing its dimensions. Okay, so now we start measuring from the center of that hole out, I believe. It's the best way to do it. So from there to there, I got what, 0.325, 0.33, we'll call it 0.33. I don't know how well this is going to dimension. Of course it goes from the center of the circle. 0.33. So I need to add the radius, right? I'm gonna have to turn on that old sketch. Now I should be able to select that circle. That one, so half that diameter. Boom. Okay, now from the other side, kind of right where it's broken, we'll call that 0.33 as well. But I am just going to go from here. Why is there so many holes? Is that just the way I'm looking at it? To here, and I'm just going to copy that one. We'll say it's symmetrical. Top to bottom. Let's just say they're all the same. And we'll say it's how about 0.325? Again, that's numbers that like somebody would actually use. 0.325 plus the diameter divided by 2. All right, let's just say that they all have that constraint. Boom. Okay. Uh, I would think that that would fully constrain that, but apparently it's not. So something's still got to be able to move. Okay, so we can rotate. So how do I lock that down? How do I want to lock that down? It looks like the peak peak of it is I guess I'm gonna really try to eyeball this. It's probably not the best idea. We're gonna go from the edge of that circle. And I'm gonna say it's 0.75. But that's the tip of that point, not the radius of it. So, oops. I'm gonna get this bigger dimension. I haven't done anything with that yet. I've measured the thickest point of it here. I'm gonna call it a 1/2 inch. And this is gonna be hard to measure with that QA, but I'm gonna say that's a 1/2 inch too. And that's after the fillet. So I'm gonna fillet this first. Oh, come on. Fillet. Failed to solve. Please try revising dimensions or constraints. I don't like that. Um, just eyeballing it here. That almost looks right, but it needs to go further on the part. That makes sense. Like I need it to extend further down. Well, that actually did what I was looking for there, didn't it? Call that 0.2. Fillet. Failed to solve. Please try revising dimensions or constraints. Probably something to do with the midpoint, maybe. I have no clue why it lets me do like half of it. It's got to be something with the dimension. Let's just start deleting dimensions then. So that was like 325 plus the radius. We'll just remember that. Actually, we'll keep that one and start deleting other ones and see what it does. Riveting entertainment here, folks. Any suggestions, feel free to throw them out there. Start. Just gonna start deleting these all these little constraints on here until we can figure out what's going on. Hey, hey. That one's 0.2. That one's 0.4. Alrighty. So how much space is this? This is not a lot of space. I'm gonna call that 1/8 of an inch. Right? So it's not gonna like this. Wonder if there's a way to dimension from. I want to be able to dimension from the actual like tangent point. So this is a crazy idea. Let's draw a line. We'll say it's tangent to this arc. And then we're going to say this line is, it wants to do an angle. So I'm going to say it's parallel to this line. And this line is 1/8 of an inch away. That looks like so much more than a. I think it's just that radius on there. You know what I'm saying, though? Oh, that's because, yeah, it's not parallel. It's got an angle to it. You see, if I take this parallel constraint off, then I drag this. Let's just try it again. Tangent. D for dimension. Cancel that. Parallel to there. So that added parallel constraints on both sides. So if I want to delete it, I probably got to do it in both places. All right, so I'm going to measure it where it actually is parallel and see what that spacing is. Like 0.1. So I'm going to change this to 0.1, measuring from what looks more like a actual tangent line that's parallel to the edge. Okay. And now, wonder if I can use that same technique over here, where I'm gonna come up with a line that's parallel to this edge and tangent to there. A line in my head. Not gonna be easy to measure. Okay, so tangent and parallel. Need longer calipers. Whatever that is. 0.279. We go a little smaller. 6. Okay, we'll try that technique again. Go here. Make a construction line. Say it's tangent to this arc. It's parallel to that line. And it's 0.266 inches away. Nice. What went so terribly wrong there? Lila. Gotta check my camera setup. Okay, it hasn't died on me yet. That's good. Um, too many like parallel lines here. Tangent spots, I mean. Can this still move like freely? That can move. This is so messed up. Okay, so this radius and this radius need to be I feel like they need to be in a line through the point. Is that an accurate assumption? What if I make a line and say that it's coincident with that radius and that radius, and this is coincident with that. Okay. And now that radius and that radius need to be in a line. They're not even close. Let's see if I can drag it. This is interesting. Again, I've never really had to take an object that exists and make it into a CAD file before. So be patient, please, if you haven't left already. Okay, and now that's going to be coincident with that. Okay, so what is left? What can still move? That can still move. I want this to be 0.26. It's not really what I wanted. I'm thankful for the undo button today. Um, why is this so difficult? Just delete that. Okay, so something, it's got to be a dimension, right? I think this dimension is constraining me. All right, so if I go, from this line to here, 0.266. And just to make it a little more obvious what's going on. How in the world is that tangent? So I guess, yeah, it would touch there. Should make this line longer or move it. There we go. All right, let's make another line like that. Make it longer. Construction line. All right, so this line is going to be tangent to that arc. It is going to be parallel to that line. And it's going to be 0.266 inches away. Okay. So how can this thing move still? We need to lock the length of it. That should be easy. And here, yeah, I keep forgetting that I've been blocking that with the camera angle the whole time. So from here to here, 1.5 inches. From here should be a line here. Where is it? I want an angle. All right, so what is this line doing? That looks like that's the line that would have been, make it a construction line. Coincident with that. Coincident with that. All right, so that angle is still free to move. We're going to say that that to there is, oh, don't be degrees. What lengths? That point to that point. 1.5. And apparently that fully constrains the sketch. Is that what we want? I mean, it doesn't look bad. Okay. Let's get the height here. I'm gonna say that's 0.75 inches. Finish the sketch. Extrude this up, 0.75. Boom. Something's not quite right there. What do I need to change? It's like a little too pointed. Let's edit the sketch. Ugh. That's not right. What happened here? What is this doing? That should just be the construction line. Oh, it's because it's still 0.4. Call that 0.3. We'll call that whatever that is. That ain't right. Almost want to go back to square one with this. It's not like everything is locked in to these constraints. Um, that didn't even do anything. Seems like. I mean, it's somewhat close. So the rotation's not right still. So how do I change that? I need to change the distances a little bit somewhere. Like the whole thing needs to rotate a little bit counterclockwise. Kind of like that. Actually, make it that. Do parametric again. I guess that didn't shift it. Need it to move. How do how do I do it? Uh I hate to just start over on this, but here's what I'm gonna do. I'm gonna save this. And then I'm gonna save as 2.0. I'm just gonna delete. Yes. Okay. All right. I hate to do that. Uh but I wasn't getting what I was wanting there. So I'm gonna start with a line that goes like that. A line that goes like that. They're both going to be construction lines. And they're going to go coincident to, come on, that point. Okay, I guess I missed this line earlier. Okay, so I'm going to draw those parallel lines again. Go like that, like that, that, parallel to that, parallel to that. Okay, so how are these parallel lines going to come in? Those are going to have to go to the corners. So that point is going to go to that line. That point's going to go to that line, and that point's going to go to that line. Where did my line go? I think this is an extraneous line that didn't get deleted. Same with that. I don't know what that is. Should have just deleted the whole sketch. Okay. No, that corner needs to be coincident with that line. I think that's done. So if I rotate these lines, okay. So just eyeballing the angle here. Why is it not doing anything that I want it to do? How the heck did that line end up? I don't claim to be an expert, folks. this, this is definitely a learning experience. Okay. Let's make our fillets now. That should probably be 0.4. How long has this been going on for? An hour and 7 minutes. Violet's getting impatient. Two. Ah. So here's where we put the centers of those radii on here and on here. I should still be able to rotate this to get the shape that I need. It's looking fairly close. I wonder why this part is shaped like it is. You know, like, does it have to be shaped exactly like this, or did they intentionally shape it so you couldn't go to the store and buy a replacement part? Like, I don't know the context of how this thing is used, but anyway. Okay, let's go back to that line. We're gonna make a construction line that is parallel to the arc. Make another line that is parallel to the arc. I keep saying parallel, but mean tangent. My apologies. It's parallel to that. Parallel to that. I think we settled on 0.1 before. 0.1. Okay, so those arcs are fully constrained. That's interesting. I keep dropping the part. Go back to here. So getting this distance. So from, wonder if I can just measure that directly. By directly, I mean eyeballing it. I need long calipers to actually measure it. So 8875. that the same on the other side? Sure. All right, so if I make another line, which is tangent, I think I used the right word that time. Construction line. Tangent to this arc. Tangent to this arc. Sorry for scratching my nose there. Let's see. Parallel. Does it have to be parallel? I think for measurement's sake, it makes it easier. Boom. 0.88, we said. So from here to there. Oh my. We're gonna let it ride and see what happens. From there to there. That. Okay. I guess because they're on a line, I can see how that would happen. It's always cool how you think you have it and then something just terribly messes it up. That's cool. Okay, so are these? Can I set that distance? That's an angle still. Ugh. And I don't think those are actually supposed to be parallel. And here I am blocking my... I keep doing that. Yeah, those aren't supposed to be parallel, so... Lila, please. Okay. Let's constrain this arc somehow. I think those are all extraneous. Okay. So these can still move in like several degrees of freedom. So okay, idea. We dimension these. I think these are already locked, but so from it'd be from like here to here. I'm gonna call it 1.5. So this dimension will be 1.5 minus 2 times that radius. Interesting. So what degrees of movement do we have left? What if I just, can I measure from here to there? Okay, so we had this measurement before, and it ended up being 0.53. Just gonna verify everything again. You know what? Move that up here and out of the center. I feel like I'm always blocking. Okay, so from the flat to the center. Oh, that's an aha moment. I think I was measuring to the edge of the circle, but I haven't put this circle in there. Let me sketch that in there. So the big circle, we're going to call it, well, hard to measure a circle that's blown out. We're going to call it 0.8, I want to say 75, because that seems like a reasonable line measurement, but yeah, we'll go 0.875. So I'm going to draw a circle. Stop dimensioning. What the heck just happened? Undo. Okay, circle. 0.875. Okay, so I need to be measuring this distance. Will it let me do that directly? Probably not. Okay, so we'll just do it the diameter way. Oh, I hope that makes things easier. I'm gonna say 0.325. So from, it's gonna be 0.325 minus half the diameter. It's got inches in it, that's why. Let's start over. 0.325 minus the diameter. It's like adding inches in automatically. 325 minus. Let's try adding it. That probably makes more sense. Come on, computer. Okay, dimension from here to there. Trying to freaking dimension negative numbers here. Okay. From here to there. 0.325 plus half the diameter. Give that a whirl. Did that just make every dimension go away? I think it did. Are we pleased with that? Not entirely. Because I feel like it needs to be like this angle. It needs to be rotated out more, if that makes sense. So how can we fix that? Okay. What did I do for this dimension? And where's the other between the radius dimensions? Did I not do two between the radius dimensions? What is this? The angle of the keyway compared to the center line of the holes should match the old piece. Thanks, Dad. That is a very good point. So I have not modeled a keyway in there yet. So the keyway is down at like this is the important part too. So how do you measure that? We could eyeball it. Almost want to like take a photo of it or something and just import it and line it up over it. I don't know if that's actually possible though. But yeah, what he's saying is there's a keyway down here that needs to line up with this part. Uh, that keyway, it's gonna be like, so I was trying to measure this earlier to see if I had the right, I had a way to make this hole. And I have like a Harbor's Freight set of drills. And this one is pretty snugly in there. And so I think that'll do. One thing that kind of concerns me is that's like a flat bottom hole. I don't know how important that is. Because mine's going to have that angled at the drill tip just a little bit. I don't think I have a small enough end mill to go that deep. Even though I did just get some new ones in, maybe I do. So anyways, that is, I think it's an 11/64 is what the box says. 0.175. So computer says 11.11 divided by 64 is we'll go with, I'll actually put 11/64 in there. It's going to be close. And then how deep is that? Because it's not quite. I want to say it's 0.1575 from the edge to this circle. So that's going to be it's going to be that diameter plus 0.1575 plus half of that. That is not right. About half that diameter. I'm still skeptical. That seems like it's way too far out there. Okay, so 0.1575 was from here to there. So there's got to be some subtraction in there. I think that's going to be this value. Subtracting out the radius. Looks better. Some lines there. Say that those lines are parallel to each other. And parallel to that line. Do some trimming. Does that look too big? Not really, it's close. Okay, so the location of that keyway, do we have any way to measure that? So what I can try to do the edge of that keyway. Or 0.3425. This will just over constrain it, I think. Okay, so I mean it's close. Gonna have to, I'd really like to fit check it once we have it. Um, okay, I'm just gonna carry on. Edit this feature. This is getting pretty close. Whether it's right or not is yet to be determined, and it will not be determined today. But uh, try to eyeball how deep that chamfer is. Well, when you have a broken part, that makes it a little easier. Oh, 7. It's 62 and a half thousandths. There's 63 thousandths. And is the keyway chamfered? It's not. So I actually need to edit that sketch and get that full circle back in there. Say that that's concentric with the other one. I don't know how do you select that though. Just say it has exactly the same diameter as the other one. That way I'll have, you know what? Let's just do that on a new sketch. Let's go up here, circle, put the other sketch up. Boom. That circle is concentric with, can I click that one? Apparently not. Well, let's say that it's dimension it, I guess. That will over constrain it. So what does it want? I guess I never specified the size. Okay, so there's that. That's where our chamfer is going to go. And I was going to do 63 thousandths on that. About 0.063. Is that more reasonable? Okay. We're getting there. I'm just going to, I'm actually not going to model chamfers on there. So is this done? Is this what are we going to call this? I don't really have a great way to measure where that hole is, unfortunately. I think we just try to make it, and then if it doesn't work, we'll make modifications and I'll ship them a new one. So here comes the more exciting part. Now we're gonna make this. Let me grab my material real quick. So while I was walking over there, I got my microphone cord caught on my shoplift that I only just put together last night. Yeah, and I like totally pulled the cord out of this microphone. So that's fun. So I guess I'm gonna have to try to fix that later, and it's just gonna be hard for you to hear me when I'm at the machine. So I'm just gonna deburr this real quick. I just also realized, so I'm fairly certain that that is the saw cut that I made. And apparently that is what the metal supplier store did when they cut that in half. I think. I don't think mine was that bad. And I did not notice that before. Yeah, this was definitely my cut because I can see my mark on there. I don't know how they made a cut that terrible. So here I'm just deburring the sharp edges off so it doesn't sit up high in the vise. And we'll get a better measurement. Just want to make sure that this stock is big enough. If it's not, I would have to cut off another piece on the chop saw. That's all I got. I don't have a bandsaw. And that thing is just plugged into a regular outlet, and it's the same like single phase circuit that everything else is on. So if I were to need to cut a new part, more than likely my internet, like basically what happened, I turned the saw on and the circuit would break or it would pop. So I'd have to go reset the breaker and my internet would go down, my computer would shut off. It's just not a good time. This is like a huge burr on there. It's ridiculous. I almost want to like take it to the chop saw again, but again, I have those same problems I just mentioned. Anyways, I think we can get away with that because that's going to be, well, shoot. I might do the first operation on, I got the soft jaws in there already. We'll make it work. Okay, so we need to create a new setup here. So this block at its thinnest point, 0.346 roughly. Just double check what the part is from end to end. And there. Yeah, click it right. It's like a flat spot. There we go. From there to there. 0.3311. Oh, yeah, we're gonna have plenty of material. Let me grab a piece of scratch paper. Okay. So 3.311 is the part. I think the other dimension was like 1.99 or something really close. And my stock, it's 3.5. Yeah, we're just gonna say the stock is 3.5. So just that's just for rough numbers. So let's see. We're gonna create a new setup. Okay, so we're doing milling, model orientation, ZX plane. So I'm going to choose a feature that's on the Z plane. I mean, that's already the correct orientation. One problem though, I want to do this in soft jaws. So I'm going to actually save this as lawnmower part soft jaws. So to do soft jaws, we actually have to cut them. I'll show you the ones I got later. They're really convenient with the orange vise. I need to go back to the design workspace. I'm going to create a sketch on the... I'm actually going to create the sketch here. And I'm going to create two rectangles. Rectangle there, rectangle there. This line's going to be collinear with that line. This line's going to be collinear with that line. They're going to be an inch long. Use that parametric. I'm going to create a reference line that goes through there. I'm going to say that it is coincident to our center point. And oh my, I must have just nudged it. No. Something is not quite right there. Those lines should be right on top of each other, but there's some kind of angle between them. Oh, that's fun. Oh, I can probably just put a... Okay, I never said that this was a... I never defined this one as vertical yet. Maybe that's my problem. Whew. Okay. They don't have to go back and redesign everything. That's good. So the midpoint of that is there. Okay, so I'm going to hide those earlier sketches now. Why are we on that plane? I wanted to be on this plane. Just gonna delete this sketch and start over. New sketch on that part. Okay. I think I can just use the R button. We're gonna say that line is collinear to that, that's collinear to that. 6 inches. That defines that one. This is 1 inch. This is the same as that one. Oh. And I always forget to do this. Like literally every time I make soft jaws. Hopefully this is the last time I have to do this. Yes. Okay, I need to create a new component from that, and we're going to call it soft jaws. Okay, and then from this body, I'm going to create components from body. Okay, so now this is my part, and this is my soft jaws. Okay, so I think I want to make this sketch on the part. Okay, we're on the right plane. R for rectangle. Linear. D for dimension, 6 inches. 1 inch. How many times have you seen me do this? Okay, so we'll make that line again. Boom, it's already got a vertical constraint. I'm going to turn on that first sketch. And say that that's a construction line. We're going to say that it's coincident with, I want to say with the midpoint, but it's not letting me select that. That'll do. The midpoint of this line is there. Okay, so now I can dimension these off of this. I like to clamp up a 1 inch piece of stock, roughly 1 inches. It really only matters when you're cutting it the first time. Is that going to be enough to hold that though? Uh, hmm. It could. If we bring it up here, we'll give it a shot. It looks like it would have something to clamp on here, and it would be clamping on this back surface too. You guys don't need to see that view anymore. So those soft jaws should work. Now, as far as the positioning of it, let's see here. We want this line to be two inches. We can go a little bigger than that. By bigger, I mean closer. Because I want to try, it's going to be done in the same operation, but I guess I'm not talking sense right now. What I'm trying to say is I want to use the soft jaws for the first operation and the second operation. That way we can use the same work coordinate system. So I hate to get it so close to the edge, but no, it'll be fine because I can let the stock hang off the other side a bit. Okay, so we'll try that. If it doesn't work, this is my last set of soft jaws before the ones I ordered come in. All right, let's just go with it. So the jaws are, I guess the height doesn't really matter as long as I don't drill into them. So we're gonna finish this sketch. And now I'm going to go make the soft jaws the active part, and I'm going to extrude that, and I'm going to extrude them down like 1/2 inch. And I actually want to select the part too, or at least the part that's covering up the jaws. Why is that little tiny piece not coming along for the ride? Same thing over here. That's not what I wanted. Can I unselect that? Not easily. Don't need to create a sketch. Undo that. I need to extrude. And I'm still in soft jaws are active. 0.5. Select that piece. Just that tiny little guy is what I need. Are you kidding me? There's still something left. I'm not going to worry about it. That's not actually part of the important part of the soft jaw. Okay. So that's like the very bottom of what's going to be holding. Let me just double check something real quick. All right, so back to this view. This is what our soft jaws look like after they're machined. So they're 2 inches tall. The part is 1/8 inches tall, roughly. So we should have plenty of space if we go up. Just under 1 inch, 7/8 or something. So I'm going to extrude. Still got the soft jaws part active. We're going to extrude that and that. Let's go 0.875, see what that looks like. And I think I want this to join. We'll go with that. And then I'm going to say modify combine. And you can only do like one body at a time, unfortunately. But we're going to cut. Keep the tool. So I'm selecting that as my tool body. Boom. Gonna modify combine. That's my target body. That's my tool body. We're gonna cut and we're gonna keep the tool. Boom. All right, so that looks like it should be holding pretty securely. All right. And now I'm gonna come over here, create a sketch on this part. And I'm just gonna make a rectangle that is however long and 2 inches wide. And it's gonna go from here. I'm gonna hide all the other sketches. Or not. That. It's gonna be 1 inch. Okay. That's gonna be adding this dimension will over constrain. I don't see why. What are you trying to constrain? The midpoint to there. Just make that a 1/4 inch. And I'm gonna put some corner relief in there. Always have trouble with this. Like if I don't make it massive, like it freaking gives me trouble when I try to machine it. Okay, so let's go solid extrude. Boom, 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 boom. Let's go down. Let's go down 300. Boom. Must have forgot to select something. Take that piece out too. Boom. I still have you guys on that screen. All right. I'm going to hide that body real quick. Let's do some fillets. F for fillet. Boom. 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 Probably don't need to say boom every time. Okay, that's actually going to be tricky. I'm going to have to modify that. Yeah, we'll touch that up later. Or maybe this fillet will touch it up. Let's go 0.20. Okay, so that's probably way more than I need. Yeah, I don't even have a flat surface here anymore, so we're gonna definitely back that off. I need that reference surface. Okay. So do I need to adjust that? I think this one needs to be a little different. edit that. Will it let me deselect it? Doesn't look like it will. Bummer. Oh, that changed. Gotta get that way out of the way. So it doesn't cause a problem as the jaws move in. That looks close. I guess if it causes a problem, I could always go back and change it. And I always hate how they end up upside down when you do this. So here's how I try to fix that. I don't think it usually works, unfortunately. I'm going to go align. I'm going to say align this with the z-axis. Boom. Modify align this with the x-axis. Boom. Okay, so we got this body floating around here. I want to join them. So I always have trouble with this part. I'm able to move it. You know what? I'm just gonna go back. I don't need to align it. Okay, so that's the part in the soft jaws. Now I'm going to copy this body, paste the body, flip over the body. Okay, and I'm going to slide it a little bit. Okay, so how much extra material do we have? Roughly 200 thou. So I want this to be 100 thou off of. Inspect, measure from this flat surface here to there. It's 150 thousandths, so I need to move it 50 thousandths to the right. I hope that's enough clamping. And I'm actually going to go back and modify that sketch. I'm going to say that's 0. Why will it not let me 0 it? Edit sketch. How about delete that? Say that is coincident with that. That gives us a little more space. And I'm only going to be making one of these at a time, so it doesn't really matter if these parts overlap with each other. If I was making a production run of these, you know, I would want to separate them so you can run one and then immediately go to the next one. Okay, so I want 100 thousandths from here to here. So that can move in 30 thousandths. So that should be our Y. For some reason, it's not. Let's try minus 0.3. Boom. Let's double check. Come on. Inspect from there to there. 100 thousandths. Okay. Um, here's where it's going to be really tight. So on this, our stock has, wait, hold place like that. So in the Y dimension, okay, we do have 2.02. That's good. So it's a little over 2 inches. 2.02, and this piece is 1.99. 1.997, 2.2. Is that what I said? 2.02. So there's not a lot of room here. What does that come out to? I'm just gonna ignore the 3/10 and just say that there's 10 thousandths on each side. That's close. So from here to here, it's 0.304. I need it to be 10 thousandths. Oh, that's close. Okay, so 0.304 minus. So if I move it in, you can all judge how bad my math is. And they're calling that the Y or the X for some reason. Okay, they're calling that Y. That's what it should be. So 0.304. 0.304. I'm trying to get it to be 10 thousandths. So close. Boom. So it should be 10 thousandths on this side, roughly. Uh, it's 5 thousandths. Should I split the difference? Call it 7.5 thousandths. Move the part 2.5 thousandths over. What, minus 0.025? How about plus 0.025? I think it's just an optical illusion there that it looks like it's overhanging. Inspect, measure, go back to programming mode, boom. 21. Can I undo what I just did? I can. It should be 5. Okay, so I want to move that. Wait, 0.025. Right? I guess not. Mental math is somewhat public mental math. It's not my forte. Why are you not grabbing the right face? All right, so that's 7 thousandths. I thought that that should be the same. Come on, click the right thing. It's only 2 thousandths. 7 minus 2 is 5. I need to move over 2.5 thousandths to balance it. Can't even see that kind of movement. What am I doing? 1,000th. 5 thousandths. Doesn't even make sense. You would think if I move the part 2 thousandths to the left, it would center it out. Because 1 would become 3 and 5 would become 3. So if this doesn't work, moving it to the left 2 thousandths minus 0.002. I'm just going to be frustrated. 7 thousandths. I move it the wrong way. Oh. Move that way 4 thousandths. This is thrilling entertainment, folks. 3 thousandths. I think I'm just going to call it at some point. 3 thousandths. Boom. It's equal. Save. All right. So we're starting off with a 2-inch block. I only need 1 inch and 1/8, I think it is. Roughly. So I'm going to start by creating. Well, basically, I want this to be from here to here. I want it to be 2 inches minus 20,000, so 1.980. So I need to move it up 185 thousandths. .185. So now from here to here, that's not what I was intending. Plus 20,000. So I got the math wrong. So if it is 0.189 and I want it to be 0.198, right? No, that's 3 thousandths. What am I talking about? It's not, it needs to be 1.980. And it's at 1.890. Boom, boom, boom. Okay, so I need to move 90 thousandths up still. If the math is right. Okay, should be 1.980. Boom. I think everything's basically where we want it now. I'm going to save that. Okay. So does this have a body in it? It's got 3 bodies in it. Okay. So my first operation I'm going to do is making the soft jaw. So we'll go to the manufacturer. I am going to hide the bodies. Boom, boom. Hide body 3 and hide body 1. And hide the sketches that made body 1. Okay. So I need to mill out this shape. This is going to be my setup. So new setup. Milling, model orientation, Z, Y, X, blah, 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 blah. So Z is that direction, X is that direction. I need to flip it so I have the right orientation. My model is going to be these two guys. All right, stock. Relative size box, no additional stock. Okay, so when I actually machine this, there's only going to be that block of aluminum that I'm clamping down on in here. But the machine doesn't know that. It thinks everything's solid, so it's actually going to go through and like mill this area down to the depth I tell it to. So stock dimensions, 6 inches, 3 inches. Oh, that's depth. That's not the word I would use, but I guess it's okay. Height. Okay, that looks good. We're gonna call this number 1, and this is gonna be lawnmower soft jaws. And work offset, we're gonna use 0. That's gonna keep it at G54, which is kind of like the default work coordinate system. One thing I'm gonna change, I'm gonna edit that. I'm gonna select a point. So we're gonna go selected point, and I'm gonna put it in the top corner. So I can actually hit that. I can probe the back side, the left side, and the top surface and get that point accurately in the machine. So select that. Boom. Okay, so now we're going to generate our first toolpath. And it's going to be a 3D adaptive clearing toolpath. I'm going to start with a 1/2 inch. We're using aluminum, so I'm going to keep using the same tools that the Titan Building Block series uses. Because we're filming it, I'm only going to do through tool. I don't want to use flood coolant if I can get away with it, because it makes a mess and gets coolant in my GoPro. We're going to speed things up a little bit today. Boom, 12,000. I'm going to go 100 inches a minute. Boom. Geometry, it knows where to go. Heights, model top, model top, model top, model bottom. I'm going to go model top. And I'm going to, actually, you know what? I'm going to go selection. That one's easy. We're going to select that surface as our bottom. Passes, tolerance, 4 thousandths is good. Machine shallow areas. Maximum shallow step over, step down. I'll just leave that for now. What is that? Both ways, minimum cavity variance, machine cavities, slot clearing, climbs, good. I don't think it's going to take that big of a cut anywhere, so we're probably fine. Flat areas. Okay, stock to leave. We'll leave 5 thousandths all around. Maximum stay down. 70% stay down, non-engagement. Bump that up to 200. Helix. That's when we enter the material for the first time. It'll helix in. Let's see what that comes up with. It's gonna think for a minute. All right, so it's gonna start down low. I'm gonna simulate that here. Start down low. Hit that contour, come up to the top, hit that. Boom. I like it. Save that. I'm going to duplicate that toolpath. And I'm going to switch to a 1/4" end mill. Boom, same thing. Only going to use through tool. We'll go 12,000 RPM. Cutting feed rate 50. Geometry is the same. Height should be the same. Passes, blah, blah, blah. Minimum roughing step down. I'm going to make this smaller because the tool's smaller. Leave same stock to leave. See what that comes up with. I want it to hit these pockets. That's the big thing. But you can't get the 1/2" tool in there. I need to hit rest machining, or this is going to take forever. From previous operation. So now it should only hit the areas it really didn't hit before. Really thinking on this one. Boom. I like it. Okay. Save that. Now I'm going to finish everything with the 1/2" tool. How far are we going down here? Should 0.875. That's going to be awfully close. But I think I got a 1" depth of cut on this end mill, so it should cut it without running into anything. Hopefully. Okay, so I'm going to do the pockets first. Start here and here. Geometry selection. Boom. Model tab. I don't know why this one it doesn't accept my defaults. Like I try to save it as a default and it just never remembers. Okay. Stock to leave. So I'm machining the bottom surface here. So that's the axial. I want that to be clean. I want that to be 0. The radial, we're going to hit up on a contour pass. So we're going to leave that at 5 thousandths. Ramp clearance height. I should just be able to plunge this. Everything's already been machined in there. That doesn't look sufficient. It's like, interesting. I don't know why it's not touching up over here. Passes, I probably gotta do like inches. Because I don't have rest machining on. Now it's saying probably. Maybe that safe distance is messing it up. Well, the rest of it's going to get touched up when we do the contour pass. It should anyways. If not, I'll have to clean it up. That's way too fast. Interesting. Okay, I'm just going to do all the pockets while I got this toolpath handy. So I'm just going to change the geometry here to these pockets. I gotta change my heights. Probably shouldn't be going through things this fast. That looks good. And then we'll just duplicate that. Boom. Select that face. That looks good. Did I not select both faces? Boom. That looks good. Now we'll do a 2D contour finishing pass. So we'll start with this contour. Make sure the arrow's on the outside. Make sure the arrow's on the outside. We're gonna go model top, model top, model top. Bottom height selection. Passes. No stock to leave. That's good. We're gonna slow it down a little bit. 40 inches a minute. Through tool coolant still. Got that at 4/10. I don't really want to mess with wear compensation. I'll probably hit some snag that would make it really boring. Okay, that looks good. Hit that, make sure the arrow's on the outside. The selection. Comes in, comes out, boom. Duplicate that toolpath. Select these contours. Good. Boom. Okay, so I think all that's left is some deburring. I'm going to use tool 15. Quarter-inch through tool only. I'll keep it at 4020. Shouldn't need any ramping, so that's not even a problem. This is the other one. See that right there? That would have got me. Like, why do they only click that little thing? That's weird. There we go. And make sure those arrows are on the outside, or else you'll totally mess everything up. Model top, model top, model top. Selected contours. That probably would work, but I'll just double check that. Okay, so we're gonna need some clearance offset here. I'm gonna bring the tool down. So this tool is 1/4 inch in diameter, so 0.25. It's got a 90-degree included angle on it. It's a 45-degree chamfer tool. So all that being said, if I want to put a 10 thousandths chamfer on here, I can plunge down up to 115 thousandths before I run out of tool. So I want to go 105 just to get it like way down. Let me get a little closer to this corner. We want 10 thou width. That's 100. Lead in, save. See what happens. Doesn't like that, huh? Or is that a separate line? Is that? I think my safe distance is 2. It's probably this chamfer clearance that's causing me issues. Make it a little smaller and see what happens. Still doesn't want to. I have no clue why it's doing that. What did I say? I'd run out at 125. That is so bizarre. Because it has the whole contour selected. I'm gonna go back to 0.105. I don't know. I'll just let it do its thing. Let's simulate that. No collisions there. Close though. Oh, I didn't think about that. You got to balance like right there. That's oh, that's probably what it is, huh? Could there be a collision with this? No. Anyways, I'm gonna back that up a little bit. Bring it a little higher up on the offset. 7.5, and we'll leave a little more space here. Go further from the edges. That way the tool's not going in quite so deep. I don't want to ram the tool holder into the part. Okay, no idea why that was so funky. Burr this edge, use the same parameters except for the height. That one works better. Gotta leave a room against there, against that corner so we don't hit that. I like that one. I don't know why the other one was causing me issues. All right. Still have to hit this surface. I should have deleting the old ones. Those arrows are both on the inside. Selection. Boom. Looks good. And now I can chamfer all the way around the top. I think that's what it's going to want to default to. Doesn't really hurt anything. Yeah, I'd have to like mess with the sketch to make it not go all the way around the backside. But I'm okay with it because those jaws stick up over the part enough that you have clearance to. I say that. I'm gonna raise that one up. This one doesn't have anything it's gonna hit like on the sides, so I'm just gonna bring it up to use just the. We'll go 50 thousandths. We'll go 40 thousandths. Don't need a chamfer clearance. Okay. So that should just about do it for the soft jaws. I'm trying to think how I want to do the order of machining here. I could get this part started and program the next tool pass while it's running, just to speed things up a bit. Let's simulate this whole thing. Speed it up. Boom, it's going to go through there. That looks good. Perfect. Smaller tool now. 1/4 inch end mill. Boom. Chamfering. That looks pretty good to me. Didn't see any collisions or anything. Close that. Let's call this soft jaw. Okay. Yeah. Let me see how I got this thing set up. I'm wondering if I should put. I'm gonna put like my little fusion screen under the corner. So I'm gonna duplicate this. Call it machine with cam. All right. I'm gonna add a video capture. Display capture. Yes. Yes, like this. Okay. So that way you can at least kind of see what I'm doing. I think this should work. So I am going to post-process this. Call it 101, Lawnmower soft jaws. Make sure I got the right post. We're still programming mode here. Looks good. Boom. What folder are we gonna put it in? CNC programs. We'll call it Lawnmower. Boom. Post it. It posted successfully. So here's what that looks like. Here's my CNC projects. It's supposed to have quick access. There we go. I'm gonna make sure that that folder is quick access. Okay. Lawnmower. Boom. So this is what it looks like. It's just a whole bunch of G code. And I am not a G code expert by any stretch. So using tool 2, 1/2 inch, tool 4's 1/4 inch, tool 15's 1/4 inch. Adaptive toolpath with tool 2. M6 does your tool change. G54 is our work coordinate. So this is basically what the machine, it takes all that work out of it for you. You just tell it what you want to do. It shows you what it thinks it's doing, and then it automatically converts everything to the, basically it's just like positional coordinates telling the machine where to be and how fast to be spinning and how fast to be moving. Like right here, G1, that's a linear move. It's going to tell it to go to Z negative 1 point, or Z negative 0.8194 at 100 inches per minute. Goes to all these different points. We're not going to dive into that, at least not today. I need my USB. I'm gonna have to unplug my camera to plug in my USB, my phone. I think we're done with that though, so. USB. I don't really need a new folder. What just happened? I just opened a new window. Lawnmower. Copy. Pass. Okay. So that is on my USB. We'll close that. Now, because I broke my microphone when I went to go over to the saw or whatever, you're not going to hear me very well while I'm at the machine. But I think because I'm going to be coming back. Oh, let's see. How can we mitigate that? If we go machining, we can give this one. Yeah. Okay, the video capture device is going here. So I guess you are recording from this. So let's see, I'm going to add this guy. Now you're getting double audio probably, so I want to hide this guy. So while I'm at the cam, okay, I think this will work. So you'll get my only audio coming from the GoPro when I'm actually in the machining mode. Boom. There. Okay, you should be able to hear something there. That's what it was. I was in the wrong ones. If I skip that, then if it's gonna have an error of some kind, it will let me know. All right, so it looks like it generated well, so I'm gonna go back to here. All right, so you can see there, it's going through that channel like it normally does. It thinks there's material there, so it's going nice and slow. And right now, it's actually hitting that stock. Sounds like I have no idea how the audio is here. If you get like an echo or something, I guess let me know. I'm gonna try to start going on to the next operation while that's running. It's a little nerve-wracking though to just let it go in the background, but I can still see it on my preview, so it kind of works out. Okay, so the bodies. I'm gonna turn on that body first for op 1. So new setup. The model is here. Got a tool change coming up. Speed up the graphics a little bit. All right, so that GoPro just stopped working in the middle of that cut. That's fun. Uh, the good news is there should be a second one floating around here somewhere. I'm going to spend a few seconds to look for it while hopefully that cools down. Patrick Baldwin, Major Baldwin, good to see you. Let's do this stuff in the Aero Lab first tour. I did not know that. I knew you worked there and you eventually were tutoring or teaching math as an enlisted guy, but that's awesome that you were working the CNC mill. So I'm gonna try to run it without the battery and see if that helps. It's probably gonna mess something up. And I'm not gonna get the camera angle just right if it does work, but yeah, the cam software, it is really, it makes it easy, to be honest. Like I watch like, you know, a series of 10 videos to make those Titans of CNC parts, and I feel relatively confident that I aren't going to mess things up too much. I don't know, we'll put it that way. Okay. So yeah, thanks for pointing that out. Uh, I clicked the wrong button there. Basically, camera issues. For camera's overheating. I think it's because of the battery. And I took the battery out, and it doesn't have enough power to actually stream at the same time. So I swapped the battery, which is really warm, from that other camera into this one. Um, and yeah, I accidentally switched to the one that was only running off the GoPro audio, so that's why it was hit and miss. Thanks for pointing that out. I'm gonna try to get this one to turn on with the hot battery in there. Want to go? Oh, camera's not happy. I'm gonna go back to the original one. This one's saying it like needs an update. No worries, got around. Well, thanks for checking in. I guess I'll probably post pictures of the finished part on Facebook or something. But enjoy your Saturday. Let's see. I have a backup plan. So here's my backup plan. I have no clue if this is gonna work. I'm gonna use my phone with a USB extension. It's a very on-the-fly solution. I hope this is a data extension and not just power, or else that's not going to work, and I'll have to move the desk really close, which might actually still work. But I'm just going to try to film this with my cell phone. Holy smokes, look at that. That that might actually work. Um, is it not? It's not showing a live feed. Why is that? It's still showing like the old, like what it was looking at before. Aha! You did it. Order that to the back. Oh, not to the bottom. Shoot. Move up. Move up. Control U. Let's try that hotkey. All right, let's move it to the front. Move to top. Order, move down. Order, move down. All right, so I'm going to copy that. Um, it's kind of sketchy. It's just like my phone is a magnet case. Um, but you can see it. So that's here. There we go. Now you should be able to hear me. So I can't get the iPhone to do audio for some reason, so you're only going to get it from this mic. Ha, ha, ha. No wonder there was no audio from the iPhone. I unplugged it. I hit the cable with my chair, I guess. So let's try. That probably sounds absolutely awful. All right. Okay, so that's doing its finishing passes right now. I'm gonna set up the stock for program 1002, Lawnmower op 1. Same work coordinate system. doing the chamfer now. Okay, this is going to be relative size box. Add stock to all sides. So our X offset is where we had a bunch, like almost 200,000. So I'm just going to say 95,000 on both sides. Y negative offset. Well, we're at 7,000, I think. Negative Z, that's going to be the big one. So the top one, we'll take 20,000 off. Negative Z, so we need to make this equal 2 inches. So it's going to be 0.198. No. It's gonna be I guess I just need 84 thousandths. Yeah, that's what I meant, 84 hundredths. I did not set this up right. ZX, Z. X selected point. It's this corner still that hasn't moved. Just gotta flip the x-axis. Okay, now we're looking good. We got 20,000. One benefit of the camera going on is remember that pass that I might have to clean up? That's interesting. Oh, that's crazy. If I put like a foil, because I said it's an inch and it's like a little wider than an inch, so I didn't machine it. It's left like a little foil there where that stock was. Turkish finish. Maybe put some smoothie on there. This looks good. I don't know why that one served. Like, it was the one that I knew I had issues with. I'll fix that. Okay, so going back to the soft jaws, actually. This pass. See that? Like, it even programmed it like it's bad. Oh. It never made it. I just never made that contour. I just completely left it out. So we'll duplicate that. That's why you gotta double check things. At least that's a forgivable mistake. Nothing got broke. running too fast on that simulation. Wrong. Arrows on the outside. Okay, so that looks good. Should be no stock to leave. Selection, that face. Well, it should have been the first contour. Right? I'm gonna put some smoothing. What contour did I do first? That one. That one. Yeah, it was just missed. Weird. Make sure there's no collision on that. Boom. What is going on there? It's like it's still not quite right. What if I make my stock accuracy higher? Oh well. So I'm gonna run just that toolpath, and I can do that by right-clicking here, post-process. I'm gonna call this 1004 Lawnmower Soft Jaw Touch-Up. And you know what? Before I do that, I'm gonna redo that chamfer. Maybe that's why this chamfer was messed up. No, that's still messed up. I'm not gonna worry about it. I'm just gonna do the contour. I don't really... The biggest reason for doing the chamfering is to like save your fingers if you're touching the jaws, and my fingers won't be in that area very often. So post-process that as 1004 Lawnmower Soft Jaw Touch-Up post. Over here, CNC programs, Lawnmower. Copy. Get my USB. Unplug the camera to use my USB. This lawnmower paste. Boom. Close. Eject. Take it out. Plug in there. We'll go to machining. Cameras. I think that's the live video. Let's do. Programs. Copy, memory, graphics. Boom, that's a really quick program. Alright. How can you actually do your finishing passes? Alright, so while I'm here, I'm going to throw this chunk of metal in there. Still think it's funny that I came out with like aluminum foil on it, but the distance wasn't dead right. So set it in there. Should be square, so it doesn't really matter. Snug up. You'll quick. The beauty of using soft jaws like that is I don't even need to set that. The beauty of setting soft jaws like that is I don't even need to probe that stock. Like, it knows roughly how big it is. So let's save this. Okay, so I guess I never actually... Or I just heard a dog bark, but it was not my dog. I don't know what that was. Okay, new setup. This is my model. I guess I never hit OK on this last time. Model orientation Z, X. Gotta flip the X. Boom. Select point. It's gonna be this corner still. Boom. Looks good. Gonna mess with that next. 1002. Got this USB cord in the way now. This is going to be the lawnmower. I want to call it Titan. It's a habit. Titan something M. Lawnmower op 1. Work offset 0. That's going to be G54 still. Relative size box. Add stock to all sides. What do we say we're going to do? 95 thousandths? Because we got 3.5 is the actual stock length. 3.311 is the modeled length. So that's 189. We're just going to round that up to 190. Divide that by 2. You get what, 95 thousandths on each side? 0.095. 0.095. That gives us a total width of 3.5001. I'll take it. Offset, we said this was 7,000, 7,000. That can't be right, apparently. That gives us a stock that's... Well, you know what? Let's just measure it real quick. I'm getting 2.02, so we have enough stock to say that it's 7,000. I don't think that'll cause an issue. All right, Z offset, positive 20,000. We're gonna skim that off the top. Z, I need that 84 thousandths again. Try 0.84. Boom. So definitely could have gotten away with thinner stock. You know what? Let's even that out a little bit just to make sure we get it even. We'll take 60 thou off the top. And what is that going to be? 780? No. I guess just 800. Does that seem right? Stock width 3.501. That should be good. Stock depth 2.09. We got 2.02. That should be good. Stock height, we'll call it 2 inches. We'll take 60 off the top and 80 on the bottom. So this is going to be sticking way up over here on op 2. All right, let's call that okay. This is going to be lawnmower op 1. First operation. See, I'm doing all this stuff and nobody could even see it. I was just talking through baloney. So anyways, I'm creating this setup. And what I was talking out loud was setting these offsets to the right height to make the part be where it needs to be. So we're going to take 60 thou off the top. It's going to be 80 thou left on the bottom. A lot of wasted material. Could have got smaller stock. But this is what I had. Because I knew it would work. And then it almost didn't work because of the wire depth. But shh. Okay. First operation, as is tradition, is the facing pass. We'll go use our 3-inch face mill. Boom. I'm gonna use no coolant on this actually, just because I'm filming. So disabled. We're gonna go 8,000 RPM. 40 inches a minute. Boom. It knows the geometry. Model top, model top, model top, model top, model top. So actually, I'm going to change the top height to 60 thousandths because that's how much stock is going to be there. And then the model top will take us right to the top of the model, not the stock. So we should get... I need to make some changes to that. I'm going to take it in multiple passes. So multiple depths, maximum step down. We'll do 40 thou with a finishing step. Finishing step down. We're just going to kiss it. 30 inches a minute. Boom, boom. 1.6 pass extension. Boom. Boom. Lead-ins don't really matter. Okay, so it's going to take a 1, a 2, and then a finishing pass. Like, such as... See our model up here, right there. Boom. Okay, that's the first operation. The next one... So, I don't have a tool for this. I'm going to have to set it up. I'm going to use my drill chuck with this Harbor Freight Special 11/64 bit. So we'll peck it. I'm not going to do through drilling. I probably will have to flood it though. It's alright, the phone's on the outside now, so we're going to go to Tool Library, Local, New Tool, Library, New Tool. It's going to be a drill. That's going to be hole making. Oh, you know what? I'm going to be really nice and even freaking spot drill for this for us. 11/64 vendor, Harbor Freight. Let them know. All right. Cutter, drill, unit, number of flutes. Probably what, 2? 2 material is high-speed steel. Geometry. Can I put in 11/64? Will it let me do that? Boom. Length. Shaft diameter. It's the same. 11/64. Tip angle is not really all that important. Overall length. So 3.21. Length below holder. Don't really know yet. Probably about that much, which is going to be 2.5. Shoulder length. Length below holder, shoulder length. All right, what's the difference here? That goes from the end of the holder to the end of the drill. This goes from, oh, the flutes. We'll call that 1.8. 1.8. Boom, boom. Let's pick something. All right, spindle speed 4,000. Plunge feed rate, we're gonna go slow, 20 inches a minute. Retract 40, sure. Coolant, flood, yeah, we'll do flood. And this is gonna be, we're gonna call this something random like tool 21, I think. Renumbered. Do I have a 21? Okay, so 21 is available. We'll renumber this. We'll call it 21. Okay, so first I'm gonna drill with my T15, which is that remove filters. My chamfer tool. So I'm going to spot drill with this. This is going to be through tool only. Good enough. Geometry. I'm going to pick that guy. And normally you want to like break edges on those holes, but this doesn't really look like it has it. So model top, model top, model top, model top. Okay, so my bottom height. Again, this is 45 degrees, so every, like if I go down 10 thousandths, I'm going to get a 20 thousandths chamfer on it. So we want to go, what's 11/64 again? Calculator. 0.171. We want to go 10% past that. So that's going to be an extra 17,000. So I need to go down about, we'll just call it an extra 8,000. So what's this plus 8,000? 0.17, we'll just call it 0.180. That divided by 2. 0.09. How about put a decimal point in there? Boom. So that'll just make the little tiniest chamfer on there. And that's the only thing we're going to use it for. Drilling, wrap it out. Boom. All right, so now I'm going to duplicate that. And select that tool 21 we just made. Boom. Flood coolant. Boom. Oh. This goes all the way through, right? So what is that, 0.75? I don't have my camera anymore. Probably be better off measuring it from the model. Yeah, it looks like 0.75. In real life, let's see what it is from here to here. 0.75. So minus 0.75. Now that doesn't get us all the way to the bottom because we get that chamfer offset. 0.8. It's close. How big is... Let me check my tooling real quick. I just got an 1/8 inch end mill in, I think. I got it for cutting steel, but maybe we could keep it here. It's going to be a little guy. I don't see any little guys in here. And maybe I didn't actually buy a 1/8 inch. That's a little guy. RV4 Fleet 1/8. So 1/8 should be 0.125, which is a smaller number. then 0.17. So here's what I'm going to do. Unfortunately, my order of tool holders I ordered on Black Friday haven't shown up yet. I guess it was actually Thanksgiving Day, but I'm not going to go down all the way. Minus 0.75. Okay. Let's call it that. Let's do that. We'll do a tap, partial retract. We'll go deep drilling, full retract. We're just going to be so gentle with this cobalt drill. We'll do 40 thousandths a peck. Tappy tap tap. See how it doesn't go. Where was that? It was just right there. Anyways, it does not go all the way down on that drilling cycle. So let's add another tool. What's our depth of cut on this actually? That's important. 1/8 by 1/8 by 1/2. But here, I'll pull the tool out. So my flute's only 1/8 of an inch, but the whole shaft is 1/8 of an inch. It's not necked down. So I should be able to bore in there with that. Or I'll break my new tool before I ever get to use it. We shall see. So I need to add a new tool, local. This is a flat end mill. It's a 1/8, what is it? Altin, I think that's what they call it. It's like ALTIN. End mill from Metal. Product ID, product link. I wonder if I can do that. Let's try that. Metal, their number is, I think it's 4047697. I guess streaming's taking up all my bandwidth. I don't know why it's going so slow. I've never tried this feature before, but it looks like it's going to take forever. I don't have tool holders around. That's the problem. I'm going to have to steal this tool holder from... I'll probably take it from my taps. So we'll use a Cat 40 ER32. Something like that. Okay, okay. I don't think this would work. I don't know how this feature is supposed to work. And maybe it doesn't actually get any information from there. Yeah. It's probably just so you can buy it back again. Sorry for wasting your time. This is carbide. It's 1/8 of an inch. Shaft diameter is also 1/8 of an inch. I guess I can get that information from that website while I have it up. Oh, come on. don't need freaking email up. All right, 4 flutes, 0.125, 0.125, minimum cutting depth. Flute length is 1/2 inch. Shoulder length. I think that's dependent on how I use it, right? So we really don't know that until we set it up. Let's just say 1 inch. Length below holder, 1 inch. Looks something like that. We're going to call this tool 22. Boom. Does this fit in the hole? It should. And this will let us machine a flat bottom on that hole, but we're going to pre-drill it with the 11/64. All right. Boom. So now I'm going to do a boring cycle, actually. I know this whole video is boring, but I'll make it extra boring here. 5,000. We'll go through tool. Go gingerly with this one. 20, 20, 20, 10, 10. Because that's what we're going to be doing, is ramping down. It's going to go slow. Yeah, we'll bore that. And whole bottom. Whole top. Model top. Model top. 4,000, supersession and computer, multiple passes. Finishing passes. Nice. Let's see if that works. So that is going to take that little hole and make it ever so slightly. It's really, I need to make this more transparent. It's not doing anybody any good. But looking at the toolpath, you can see it goes down. It's supposed to do some finishing moves at the bottom, I thought. Anyways, we'll go with it. You know, I suppose we don't need to do that at this step. Let's save this for later. Let's do some 3D adaptives. Use that 1/2 inch tool. Boom. Through tool. 12,000. 100 inches a minute. 100, that's 10. Stock contours. Model top, model top, model top, model bottom. So we have model bottom here. We're actually going to go past it. Minus 20,000. That way we get that contour just a little deeper. Passes. Optimal load, we'll go 0.1. Boom, 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 boom. Stock to leave 5,000ths. Stay down 70%. Helix into the blind spots. See what it does. It's gonna think for a minute. Vark Tech. that like a school? I don't know what VarkTech means. Okay, why did it not machine the insides here? It should get everything. Undo. Flat areas. I bet that's what it is. Machine shallow areas. Flat area detection. Let's run it again. It's really thinking. Oh well. Let's duplicate that toolpath. We'll go rest machining from that previous one. And we'll put stock contours just on this guy. How do you like that? Should be ramping down. That's not what I expected. I guess we could bore it out. Probably got something to do with like a lead in, like a lead in radius that's too big or something. Five thousandths. This is the problem. That ramp diameter is huge. Point. And that might be too big though. Okay, so it hit that. But look how much bigger I can make that ramp diameter. So I'm going to delete this, edit this one. Helical ramp diameter. What did I say for that one? 0.025? Let's go 0.1. How big are these holes? 0.314. I could pre-drill those. Yeah, let's do that. Add a drilling operation. Geometry, we'll go that hole, and that hole. Heights, it's going to be all the way through. Pop through 100 thou. Okay, tool is going to be, we'll use a 1/4 inch carbide. I think that's the closest. That's a tap. Don't want to tap. 0.2283. Forgot about this guy. Do I have that guy installed? What is it? Tool. Two, 7, 4. We'll try it. Okay, so this we'll do flood. I'm not gonna peck it. I should peck it, but it's a solid carbide drill. That's pretty deep, isn't it? How deep is that drill? It's got a 1 inch flute length. Ugh. I'm gonna simulate it and watch it shank out. Oh, nope, I gotta reorder it. I want to do this before the adaptive. So there's still gonna be material there when it comes down. What? Why is it? It's saying it's colliding way earlier than it should be. Uh, I guess I'm just not going to go down that deep. I'm only going to go down. Model tap, model tap, model tap. Model bottom, 0.2. It doesn't really gain me much. I'm just going to delete this. We'll just bore those holes. Sorry for the waste of time there. So, okay, so we can bore that out. Boom. That looks good. Let's think about what we need to finish up here. So we need to get into here. So why is it leaving so much stock there? See what I'm talking about? Oh, that's the chamfer. Duh. It is getting the right depth. Okay, so we'll clean that up with the, well, that 1/8 is small. This tool will even have an inch of stick out. That's the wrong tool, that's a drill. Where did my little end mill go? There's the lid for it. So organized. Ah, here it is. It was wrapped up in a paper towel. Yeah, I think we could clean that up with the 1/8. So I'm gonna go 2D pocket. Use that 1/2 inch still through tool, 12,000, 100, 100. We're gonna slow this down. We'll go 50, 50, 50, 50, 50. Geometry. This pocket, please. Selection. Again, it's at stock top. Don't know why. It doesn't remember my defaults. We're gonna leave radially 5 thousandths. Take it clean on the depth. Shouldn't need to helix. We'll plunge. Check my heights one more time. Boom. All right, so it plunges down. So we do have to get that hole. How long? We get 1.25 inches of reach with this end mill. But that hole is... How big is the hole? Diameter 0.4. So I can't use the 1/2 inch end mill on that. I hate to do this. I think I'm gonna have to get those holes on the second operation. Yeah. I don't think I have a tool long enough to go into there. All right, we'll work around that. 2D adaptive, 2D pocket. We'll duplicate that, do a 2D pocket. Is it really a pocket? It's more like a face. But we'll leave it as pocket and see what it does. Hit that guy. Height selection. Stock to leave. Rate to leave 5,000. Boom. Okay. Plunge. It's gonna have a kind of interesting look to it. And then this I don't actually need to finish. That's 20 thousandths below the part already. So boom. I keep saying boom. That's a Titans of CNC thing. 2D contour. With the 1/2 inch. Geometry. Hit that guy as best you can with a 1/2 inch tool. Tap, model tap, model tap. How about selection? That guy. Passes. We'll do some smoothing. Okay. In computer, good. Should be no stock to leave, good. I don't know how it's going to handle that. So yeah, it's just going to trace the circle. It's very similar to the last pass, but this time we're touching the wall instead of being 5 thousandths off. So we'll contour this. We'll contour this. And then we'll pull up that 1/8 inch face mill. So contour this guy. It's on the outside. Selection this guy. Boom. Boom. Duplicate. Almost duplicated it a second time for no reason. Contour this guy. Delete this guy. Selection. This guy. Minus 0.02. Smoothing. Okay. Boom. All right, this is going to be the fun part. Trying to make these go away. So I need a little tool. I'm going to do a 3D adaptive on there. I'm going to say the bottom height is selection, this guy. I'll say that guy actually, just in case. They should be the same, but... Alright, our tool is going to be tool 22 in our local library. 1/8 inch, dude. 1/2 inch cutting flute. So... I don't know speeds and feeds. Just learn as we go. If it works, then we'll keep it. Or maybe ramp it up. 25, 25, 15, 15. Through tool. Okay, rest machining. Yeah, sounds good. From previous operations. All right, so here's where it's going to be interesting. Keep that optimum load nice and low. Maximum roughing step down. If we left that at 1.25 inches, we would have a bad day. I'm going to go 0.4. Because our tool's only got a 1/2 inch of cutting flutes on it. So, yeah. Boom, boom. I don't need. Let's see what this does. It might do nothing. It's thinking, so it's going to do something. Do interesting how it kind of like bounces around. Let's simulate that slowly. So it plunges in, it rounds it out. It's kind of a big cut there. I don't know why it does these little curly cues. We've already finished that area. And it should be leaving stock, so... What are you doing? What? We need to put a stock selection on there. It still wants to come outside. So maybe it's not a stock selection, maybe it's a machining boundary. Okay, so we fixed that. We're still doing curly cues in there. We never did a... Yeah, I never contoured that inside. I said I'd do that with the 1/8 inch. I lied. I don't want to do that with an 1/8 inch because we're taking multiple depths of cut. So I'm going to machine this out with the 1/8 inch like it's doing. And then, you know what, I'm actually going to reduce that optimal load. It's a little tool. I don't really know what it's capable of. Let's go 0.05. Machine shallow areas. Nice. Okay, so just to be sure, this from here to here is 0.75. So our 1 inch stick out should be fine. It's fine. Okay, now I need to... We're gonna 2D pocket this guy. Rest machining. The previous tool diameter was 0.5. Why does it not remember model top on these? Selection, boom. Radial stock, or stock to leave, we'll leave 5,000ths radially, nothing axially. Check my heights again. Okay. I should plunge in there. I like it. Make sure it doesn't smack into anything. Boom. So now, I don't know how this is going to work. I'm going to do a 2D contour. Rest machining. 1/2 inch and mill. Again, did I not duplicate? No, it's a new path, that's why. Model top. Model top selection. Boom. Okay, so here, how do I tell it? I'm gonna have to do multiple depths. Maximum roughing step down. 0.04. That seems too low. I'm gonna do 3. Finishing step down of, is this step down or step over? That's a difference. I have no clue what that's gonna do. Finish feed rate, boom, 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 boom. Smoothing. Safe distance. That's a huge safe distance. What tool do I have? Still have the 1/8 inch selected. Okay. Send it. Wow. That's like exactly what I was hoping for. It's beautiful. Okay. Now, we're gonna go back to the 1/2 inch. Do a 2D contour of this with the 1/2 inch. Boom. Sure. Model top. All right, so that should be kissing just a little bit of material off of the sides. Doesn't look like it though. I don't remember doing that toolpath. Did a pocket. Did I leave radial stock here? Should have, yeah. I'm gonna simulate that with high resolution on the stock and see what it does. Oh well, I think it's doing mostly what I want it to. Okay, so there is a little chamfer there. I'm gonna switch to a 1/4 inch end mill and do a little bit of stuff. Probably should do that before all these finishing passes though. So let's do a 2D adaptive clearing with a 1/4 inch end mill. Okay, 8,000. 30, 30, 30, 30. We'll go 20 and 20. Through tool. Heights, model bottom minus 0.02. Top, model top. Rest machining from previous operations. We're gonna have to change that when we move it. Maximum roughing step down. Don't want to go over the tool area there. Machine cavities, yes. I don't think we need flat area detection. We'll leave some stock. Basically just doing this to get the chamfers on here. like to cut the holes out so I can chamfer around them later. Probably need to helix in. I am helixing in. Why did it not pick up these holes? Probably because the ramp diameter is too big. Still too big? Quarter inch. 0.314. Leaving 5 thousandths. It's getting close, huh? I really wish it would. Let's try plunging it, see what happens. Still doesn't hit these holes. Flat area detection, maybe. Minimum cutting radius. Helix in. 15 thousandths. I guess I should probably do the math on how much space I have to play with to get into these holes. Not enough. Maybe I'll have to pre-drill it. I'm gonna make this like, and that's stupid to be ramping if you're just pre-drilling. Like if you're basically just plunging at that point. Okay. Forget that plan. We're just gonna kiss it with a chamfer mill. How's that sound? I think tool 14 is my thicker chamfer mill. That's a 3/8, so what is that, 0.375? Public math. 0.375, this was... Okay, so we can chamfer that. This one will probably have to like chase the chamfer around. So these two, I guess I'm going to plunge them all. Select the 3/8 inch, I think it's tool 14. Yeah, I'll leave those speeds and feeds through tool. Geometry, boom, boom, boom. So this is just like spotting those holes, right? Selection, boom. Top height. Offset. All right, so again, this hole 0.314, so half of that. We'll add an extra 30 thou to it, so we want 0.34 roughly. 0.344. 0.344 divided by 2. What is that, like 172? I'll take it. Okay. And then I'm just gonna, this is kind of sketchy, but I don't know why that went to 0. Through tool. We're gonna chamfer that, that, and that. Selection, boom. All right, chamfer width. Actually, we only need to chamfer this one. We chamfered the other ones, right, with the whole depth thickness. We're gonna chamfer this guy 0.01. Boot to doot. I think we have enough clearance in there. Should be nothing to hit. Famous last words. Boom. So let's see how things simulate from like here on out. I think I can do that. So we come in, we touch up the sides after we did the other thing. We come down, we spot those holes. That's going to leave us enough chamfer on those. Let's see how it overlaps the hole a little bit. And then we remove some material there, so we'll come around. I think that should work, right? Okay. We're getting there, folks. We're getting there. Still have to do this big chamfer. And then we'll chamfer the outside pretty generously too. It's got like an actual, like a fillet, a radius on the real part. But yeah. Okay, let's duplicate that chamfer. Geometry, we'll select this guy. Actually, then I added somewhere. I added. Did I not? I could have swore I added a sketch to. Well, we can do it here. Because this hole is not chamfered. Does it matter? Yeah, it definitely matters if we're going at any significant depth. So really, I want to select that body. That's what I want, because we modeled that chamfer. So, will it let me do that? Can I select a feature? No, I have to select a contour. Let's see what it does, because it knows there's not a chamfer modeled there, so we'll go 0. Gonna have to go a little lower than that. Empty toolpath. It's probably because I selected the it's supposed to know when you model the chamfer. Chamfer width. What did we say it was? It was like 62 thousandths or something, right? From here to here. Of course, there it gives me a not the straight line. There's a way to break that out into X and Y's. I thought. Measure from here to here. All right, 63. So that's going to be our chamfer depth. Width. 0.063. Boom. Empty toolpath. really doesn't like that. All right, let's add that circle. Create a sketch there. Boom. 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 Chamfer that circle for me. Boom. On the inside. 63,000 deep. What is your major malfunction? Is my chamfer offset? That's what it is. It's like, hey, buddy. 0.09. This is making me question my sanity here. What's oh, heights. It's gotta be heights, right? Did I just... Yeah. 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 Well, that makes me want to change everything. So let's go back to selecting the contour, this top line, and see if it remembers that the model is there. And we'll go selection face. Or we'll go model top. How about that? Boom, boom. Okay, so it does bring the chamfer mill in here, but it recognizes how deep it needs to go. That's nice. I think there's no harm in letting it follow that toolpath. I think it doesn't actually make contact back there. Okay, so that's chamfered. Now we'll duplicate that. We will chamfer the outside. Make sure the arrow's on the outside. That would have ruined the whole part. I've done that so many times where it defaults to the inside like that, and then you get a V groove running around the top part. So you gotta be really careful about those arrows. In this one, we're gonna just add 0.10. Just kissing it a little bit. Okay. This next one, we're gonna have to be a little careful because we can hit it here, so we're gonna have to really offset the tool. So, boom, boom. Selection. Okay, so again, this is a 3/8, so that's 0.375, right? Yeah, that sounds right. 0.375. So we can go about half of that. It's 0.1. What's it? 0.1725. So what if we take this down 0.16? That should get us well out of the way of the sides there, and let us use just the very edge of this tool up here. Boom. Clearance, 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 boom. Chasing it around. You gotta get a 3D mouse. These things are amazing. Okay. That's done. Can't chamfer that side. I do dare say that this is finished. What could I possibly be forgetting? We're gonna make that hole bigger on op 2. We just need to get the chamfer in there. We're not chamfering that. I mean, we could maybe just break the edge if we wanted to. Oh, this part doesn't have it. We'll leave it. Yeah, let's simulate that whole thing. Boom. 3 passes. I forgot we're using that drill. That's fun. Boom, boom, boom. Cleaning it up. Cleaning it up, ramping down. It's a tiny little ramp. Clean up the face, clean up the sides, clean up the sides. Little tiny guy. Cleans up in there. Finish it, spot it, chamfer it, boom, boom. All right. So I need to set up 2 tools before we start. We need to get that drill in there and we need to get this little end mill in there. So I need to steal a chuck and I need to steal an ER collet. So let's go to the machine. There's conveniently a chuck loaded. So switching drills at this point, taking this one out, putting this guy in. All right, so this is tool 21. That was fun. This guy. All right, so tool 21. Can you hear me somewhere? Okay, it looks like you can still hear me on the big microphone. So tool 21. We need to add that. So I need to go to current commands, tools, spindle. It says it's tool 9. We're gonna call it tool 21. Offset, length geometry. I'm gonna do this through edit mode. I'm gonna edit VPS, go back. Need tool offsets. We're gonna get auto length, rotating. Tool type is number 1 a drill. Length. So there's this really cool tool. The dude did not put the name of his company on there. I'll have to look that up. But this thing gives you, because the tool length is measured from like an invisible gauge length, you don't really know where to put it. This thing gives you like a solid datum that goes right in the tool holder. So that's 5.9 inches. Diameter was what, 0.17. Don't really care. I don't think. Okay, so we'll run that. That's going to go over to the tool setter. I should have grabbed that. Should grab the PR collet for the end mill, so I could have done that while this was running, but whatever. That's time is wasted. So I think my taps are like T14. I'll take that one. So I'm going to MDI T14. I'm not going to change it forward. Nope, I used that. I guess. T11. Let's go to the tool library. So I need a tappy tap tap. Which one was that? Tool 12. So we'll take tool 12. See board. Right. Steal this guy. Right there, that was probably fun, huh? We're just taking collets out here. This is the tap I'm taking out. Here's the end mill I'm putting in. So I need to get a much smaller collet. I don't even know if I'll be able to fit it in this collet, the ER32. I might need to get a smaller one. But it's a brand new one. I haven't used one so small for this ER32 size. Getting plastic wrap off. This is tool 22. So put collets in, snap it in. I don't even know if this, it might compress enough to hold it. We'll see. So I think this is not going to be good. If I ran this, I probably would hit the tool holder onto the part just barely. I'm going to go out a little further though. All right, so this is not going to be a very rigid setup, but it's going to have plenty of stick out. That's almost going to be too. I worry about it. Well, we're taking pretty light cuts. I'll move it down a little bit. We get like 1.2 on here. That'll be good. Yeah, 1.3. I'll take it. So this is tool 22. We're calling it. Current commands, tool table. 22 is in the spindle. Tool type is end mill. Is what we got there? About 5.1. Diameter is 0.125. Send it. Okay, just double checking. Tool 21, tool 22, both have links, so that's good. Down. That's up my tool sighter. I am going to now print a setup sheet. Well, first I'm going to post-process. Lawnmower 1002. Here we'll go back to programming here. 1002, lawnmower, blah, blah, blah. Post that. That's going to take a bit longer with all the 3D toolpaths. Hasn't shown up yet. There we go. And now I'm going to right-click this and setup sheet. I'm going to go to CNC programs, lawnmower, put it there. Boom. Okay, so I'm going to print that. 2 sheets of paper, okay. Should be printing. And I'm going to do that. I'm just going to double check that all my tools look good. Go back to the machine. Okay, so we got 6 tools. NDI T1 our 3-inch straight though. Good. Forward. It should be a 1/2 inch. That's just because the pocket is only we have one heavy tool pocket, so that gets messed up. Not heavy, large. This one's a large tool, so these three pockets on the tool changer, unfortunately. Alright, so next is T14. This is going to be our 3/8 inch chamfer now. Looks good. T15. I don't remember using that guy. When did I use T15? Oh, yeah, I used T15 for that little hex drill at the beginning for the other hole, that first drill. T21. Good, that is our drill. T22 should be the I'm going to double check my work offset on the computer. That's the front of the jaw there, so we don't need to change that. Go through my tool offsets. 22's got a length, 21's got a length, 15's got a length, 14's got a length. Okay, so I'm going to run the. First, I need to get the program on there. I'm getting ahead of myself here. So I need to unplug the phone. I like how it leaves a solid image. That's kind of nice. When you unplug it, instead of going black, it just leaves whatever was there last. Programming's lawnmower. This is 1002. USB, Haas, lawnmower, 1002, close that, boom, eject, boom, machining. Okay, now I can plug in my camera. See if this guy updates on us here. Yep. Alright, so this program, up to USB. Lawnmower 1002, F2 to copy it to memory. Get the 1002 exists, go ahead and copy it. That loads it to memory. Memory graphics. I'm going to run the simulation on the graphics. Looks Good, looks good, no errors. Alright, here we go. Everything look good? Do a tool change here. Before I wrap it down. No coolant on this, unfortunately. Beautiful. It only cut the front, you see that? Like it's not square, the stock's not square in there, but that cleaned it up. Good thing we took 60,000, not 20. That looks like a finished pass. 100% rapids. Intermediate one for the heavy large tool change. Alright, spotting that little hole for the middle. Probably don't need coolant for this for the can't turn it off once the program's in. Do it now for the stuff here. So this is PEX drilling all the way down. I never set my coolant height. Adjusting the programmable coolant nozzle. I forgot to set a height for that tool. Alright. Stop it here. Let that coolant spray off of that. So this will be the faster tool, about 100 inches a minute. Tiny little ramp. Pocket tool path. It'll get the contours. This is going to be switching to the small end mill to mill up that little pocket. This one could go bad, I don't know. I think it's still there. It might have just broke. That's like the extraneous curly cues that it's doing there. Not on the line. But we're touching it up with a 1/2 inch after this, so it shouldn't be a problem. I think that was making cuts and not shanking out, but it's hard to tell. Curious to see what that looks like. I'm actually going to stop and hold there. Take you inside and see what we're looking at. Ooh. Looks pretty good to me. Alright, this is that cleanup pass. I don't know why flood fluid's on. Should be 3-2. Little programming error there. I just want to check that edge. Pretty good. Alright, so this is going to be drilling those holes, chamfering them. Same here. Can't even see it with the cooler. Now it's going to trace out that hole in the middle. Big cut here. Little chamfer break edge here. Edge break. Should be it. Yep. Cool. So, came out like that. I think it fits in like this. That looks pretty good. That face mill is going to get some work on this one. Holy smokes. Making a lot of chips on this face. On to app 2. So we're gonna put that body on, hide that body and that sketch. I don't know where that sketch is coming from. That sketch is hidden. Sketches. Boom. All right, sorry, wrong screen. Hopefully you can still hear me. Hopefully you enjoyed that video and it worked for you like it was supposed to. So this second operation, we're going to create a new setup. Model is going to be this guy, and if this works, well, I need to set my Z and X still. So Z, X, flip the X, select point. This guy hasn't changed. Okay, so from preceding setup, continue rest machining. This guy. That should work. I don't know why it's not working. Lawnmower op 2. Okay, so that's what I wanted, but I don't want it there. I want it here. How do I get that? Let's edit that. I don't know why I did that, but I don't think it changed anything. Oh well, we'll try to replicate it here. We'll go relative size box. Add stock to all sides. So Z offset, this is going to be Z plus. This is the big one. So how much stock did we leave? I'm just going to put a number in. I think it's like 0.86, something like that. Can I go from solid? That. I really want to do from relative last setup. I mean, it knows it's there, it's just in the wrong spot. But, okay, relative stock. Relative size, box. 0.86. That actually looks right, because the stock height was 0.2. 2.0, but we took 60 thou off, right? So 0.8. I think that's right. But our reference is here, so. And our part should be squarely held in soft jaws, so I think we'll survive. Op 1, 2D face mill, and boy is this thing going to be working. Building blocks, 3-inch face mill. I'm gonna go no coolant. If I need to, I'll put it on manually. 4,000. And we'll go 8,000. 50, 50, 50, 50. 30? Geometry, it knows. Height, model top, model top, model top, model top, model top. Up here, we're gonna go 0.8. So much. So then all these are gonna have to move. 1, 1.2, 1.4. Okay, so model top. Multiple depths. Yes, please. Otherwise, we will definitely break something. 80 thousandths. Finishing step. We'll go slower. We'll go 40 inches a minute and call it. We'll just kiss off 5 thousandths at the end. Leave no stock. Pass extension 1.6. Stock offset 0. Stock. Okay, maximum stay down, blah, blah, blah. Don't really need lead-ins, but doesn't hurt. Boom. That's going to be a lot of face milling. And we have to remember this is actually milled already, so that material is not there. So I don't know if this is necessary, and I don't know if it's going to help or hurt, but I want to add probing. So I'm going to probe work coordinate system with my local probe. We'll go 15 inches a minute. Preset geometry. Probe that guy. It doesn't like that. Probe this guy. That's fun. That approach should be fine. Well, I'll make it smaller. 0.01. We'll go 0.1. Use selection point. We're gonna go model top on this guy. Model top. And most of this material has been, I mean, 1 inch, that's pretty high. We're gonna go 0.3. 2, probing surface top, minus 0.3. How about 0.2? About 0.15. Maybe. Okay. We don't have any holes to pick up from, which is unfortunate. I don't have the feature that probes geometry either. I wonder, will it let me probe like an angled surface? Probe surface. It's like, I can't do that, bro. Doesn't like that. How about that surface? I can probe it in 3 spots. How about this side, since that's the fixed jaw? Beep, beep, beep. I like it. It's kind of fun. I don't know what that's going to do, but it's supposed to update the work coordinate system and let it know where if the part's in the right spot. Well, then could I probe these guys too? Like this edge? Going crazy on probing here, sorry. I just want to make sure those holes are perfectly lined up. Yeah, full. Cool, send it. Not sure what we're going to benefit from that, but we'll do it. Okay, so now we need to drill / bore these holes. We got a 1/4 inch end mill we could use for that. I think it's got a 1 inch depth of cut. And the part's much smaller now, so I'm going to pre-drill these. Boom. We'll use that, that's the tool I just took, isn't it? Invalid tool. So the tool that I should have used is no longer there. But we got a 1/4 inch. Tool 8. Make sure that's there. Perfect. Okay. Tool 8, flood coolant, 4,000 RPM, blah, blah, blah. Geometry, this guy, and this guy. All right, so we're gonna go model bottom on this guy. And we're drilling into air down here, so as long as we don't shank out the tool, we should be good. Oh, we don't need to go that deep at all, my bad. We'll go model top then, minus 1/2 inch. That should be good. Right? Can I see from there? Not really. Yeah, I think that should work. Don't need to. This is a solid carbide drill. We'll just send it. I need to get some more through coolant drills. That'd be nice. I haven't tried one yet, but I just received one yesterday. Okay, let's do some boring. I think that's a good way to go. We'll use a 1/2 inch end mill. Through tool. Yeah, we'll go 4,000. 20, 20, 20, 20, 20. Whatever. Go that guy, and that guy. Model top, model top, model top. Whole bottom, minus 0.1. We'll do in computer. We'll do a nice finish pass with a 0.005 step over. See what that does. See that? It's flashing like it has a collision, but it didn't stop. What would it be colliding with? I'm just going to put smaller radiuses on it, like smaller lead-ins and lead-outs. That's pretty small though. Well, that doesn't highlight red anymore. So I think all we got to do now is we'll do an edge break and some chamfers on here. These are bigger. I'm gonna go 20 thou chamfers on the holes and 10 thou on the edge break. 2D chamfer. Building blocks, 3/8 inch. Keep the speeds and feeds. We'll go through tool. Boom. Contour selection. So this guy on the inside, on the inside, on the inside. Model top, selected contours. Boom. Depth, we're going 20 thou on these. Go 40 thou deep. Don't need a clearance. Don't really need lead-ins, but we'll see what it does. Boom. And then just duplicate that. Boom. Make sure this one is on the outside. It is. contours, passes. We'll just go 10 thou on this guy. Just a little edge break. All right, boom. So that should be the whole operation. A whole bunch of face milling. Probing. Don't know why it's saying, oh, it thinks there's stock there. There's not going to be stock there. It thinks it's cutting into stock with the, that's funny. I'll make sure there's no stock before it does that. So that was, did I spot drill that, or I just drilled this? Do I want to spot drill them first? I don't think we need to, but I will. So that should be exactly the same as that one. So I'm going to edit the first one. Select that. He's going to add an extra tool change or two, but I'm okay with it. Looks like Lila's eating her food. Finally got some food out here for her. All right. What are we at? What are we at? Chamfer. They're not showing up. Gotta hide the filter. So this guy. Again, this hole is 0.314. So we want to go, we'll say 30 thou over that. So 0.344 divided by 2. 0.172. I don't trust that. 0.314 plus 0.03. 172? I said 0.142, didn't I? I was thinking 14 in my head. All right, so we'll go 0.172 deep on these. Right. That's why I said 0.172. Just add a little chamfer. I guess we're doing that already though, aren't we? Doesn't matter. We'll just keep it redundant. But I do want to center drill these. I know you don't have to, but I don't want to break a drill on the live stream. I should be drilling all the way through. The stock's not. Simulate it one more time. An error occurred during stock calculation. I don't like that. Save. Simulate. Faster. Next operation. Next operation. Spot drill. Drill. Or those little finish pass on the boring. Chamfer. Mission complete. All right, so that is saved. Let's post-process that. Lila, please don't. Come here. It's been a while. We're 5 hours deep at this point. if anybody. I don't even know if my dad is sticking around at this point, and he's the one receiving this part. All right, so we'll call this Lawnmower Op 2. We will post-process that. You know, I swear I just did that. Yes. CNC programs, lawnmower. Machine just kind of went to rest. Haas, lawnmower. When did I put? Oh, you know what? I'm calling this 1003. Not that it really matters, but I for some reason called the soft jaws 1001. Post process 1003. Success, hopefully. There's the success. CNC programs, lawnmower 1003. Boom. Lawnmower. Close. Boom. Let's go make a whole bunch of chips. Gotta plug the phone back in though. Boom. Plus lawnmower. Oops, don't want the whole thing. Cancel. 1003. Copy. The memory. Yes. Yes, overwrite. Memory. Graphics. Simulate. Boom. That was quick. All right, here we go. It's working. It's working. That might be too big. That stock was more than 2 inches thick. The way covers love getting pepper with chips in it. Splash it. Now I'm hitting the pink. There's the finishing pass. Let's stop it there. Oh, that's a garbage finish with that pull. I'm gonna cheat here. All right. I'm gonna add one. I'm gonna add a length wear of 0.0005. So I'm gonna check the machine and thinking that is 10 thousandths longer than it is. Let's see. Stop the program. The last line I was on was 190. Memory. Run it to line 155. I got cycle restart on. No guarantees this works. If it does work, it's gonna skim over it like once and come back and do that finish pass 5/10,000ths further. It's not the worst, but it's got like stripes in it. I'm gonna try it again with 1,000ths off. Add 1,000 to whatever that was. Oh, reset. What I said that was last time. Line 1. Line 155. Going on. It's a little better. Oh, I shouldn't be doing this. Taking too long. I'm gonna add one more 1,000 and call it a day. Memory program reset. And 155 search. Going on. Moving that layer offset. Broken that, there we go. No. Error there. what happened there was on this probing cycle, when it's on the back of the part, it came and hit the vise before it hit the part. So it's not going to hurt itself. Like, it's smart enough, but I should have seen that. Look at that. So all of these heights are going to have to come up a little bit. We'll start with this one, even though it doesn't matter. We're just going to go minus 0.1. Let's see if that looks good. I don't know if that's enough clearance, to be honest. Approach. What if I make it 0? Let's not do that. Let's try negative 0.1, because you want the ball, you know, if the ball doesn't hit on center, it's not going to be accurate. So if the ball's too high and it hits like up here on the ball, you're going to have a bad time. So I hope this is all it takes to fix this issue. One. Okay. I'm just gonna, well, it's recalculated and everything, but post 1003, overwrite, boom, lawnmower 1003 at 547, boom, boom, overwrite, yes, updated at 547, close, eject. Go back to the machining view. That's an old picture. Let's update it for you by plugging in the camera. Boom. All right, so that left off on line N275. Three, happy. It's not going to let me do it because that's the active file. So select program. Fix spin the warm up. USB 1000. Copy the memory. Overwrite. Program. M275. I'm going to search for that. And we're just going to go to the first operation of probing the cycle. But it's going to do a tool change, I believe. That's how this look ahead thing works. So it's going to. I'm wrong. Oh, I didn't actually touch that first one, did it? I don't know if that's helping or hurting us, but we're doing it. So now we're going to spot drill those holes. Ah. This should have been true tool. Not going to worry about it. Spot the holes. Now we drill the holes. This should be plugged in. And it is. Plunge right through. Just takes it. All those chambers are deep. Oh, we have to open up the boards though, so it's probably on Pour the holes out. Finishing pass. Pour the holes out. Trace that middle hole and then the outside of the part. As long as I don't have the air on the inside, it should be a good part. I guess I could trace that. About that. This is the moment of truth to see if the crew did everything for us. It's looking good so far. Put this over here. I think I had this way before. Okay. So that's what we started with. And that's our first attempt. I say first attempt. The shape looks a little different. Like this is a larger radius than that. I don't know what's going on with the surface finish either. Maybe there's like a chipped tooth on that end mill. Maybe I drove it too hard. Don't have the speeds and feeds right, perhaps. The holes line up pretty good. Kind of hard to see, but don't really have a way. How backwards is this? Did I mess up that badly? Oh, it's just because they're opposite. If you had two of these parts, you couldn't make them do that and line up the way I was trying to make it. We just kind of have to eyeball it. So, Dad, if you're still out there, do you think that's close enough, or should I make one that's a little thicker around here? Huh. Anyways, I might tweak this later. We'll see. But that was fun. I feel like I learned something. I'm not sure if I learned a specific something, but that was the first time I like tried milling a flat little pocket. First time reverse engineering anything. I mean, maybe this is good that it's thinner, because he wants it to break. So it'll break like right through here. We got less material here. Still don't like that finish. For being like the 11th part I've ever made, I'm not too upset about it. Here's the stripes you can see on that finish pass where I was running it dry without coolant, and it was like scratching. You can literally catch those with your fingernails. Yeah, I would take a stone to it, but I don't want to load up the stone. This is probably a bad idea. Oh yeah, that was awful. Don't do that. I need Scotch-Brite. That would probably work to buff it up. Dad says it looks like it'll work. So I'll bring this home at Christmas time and we can fit it in and see what happens. And then we'll make modifications from there. All right. Well, let's see. Do I have a screen that's